It's about 30 minutes long, and we'll see what's under the hood here. Let me see, I need to say okay. Okay, so I'm going to try to get through that, and there'll be 2 question and answer periods here as I go along, but if you want to interrupt me, that's okay. I'd like for the questions initially to be focused on segments, things that are of interest to everyone. And then if there's time, I've got about 15 minutes. I can talk about triangulation and clustering, which involves the segments. And I'm glad at that time near the end to whatever time we have left, I'll talk about anything genetic genealogy that you want. So let's see if I can get this to work. Okay. First is this disclaimers. I want to get, I don't want to do that. Okay, disclaimers. You might get unexpected results, and I've tested at all the companies, but I don't represent any of them. I am a project surname coordinator at Family Tree DNA, and I provide advice assistance to GEDmatch, and I speak for myself on all of this. 50 years of genealogy research that I've done, 22 years with the DNA. And so I like to give it to you straight from genealogist to genealogist, kind of the unvarnished version of this. Okay, so the agenda is going to be a brief overview of this. We'll talk about DNA segments, your DNA segments, and shared DNA segments, 3 separate concepts right here. And then I'll break for questions and answers if we haven't had any by then. And then if there's time, we'll talk about grouping segments. Okay, so a segment, it's a small part of our full DNA, and it can be measured. Your segments are on one chromosome that you get from your parent, from one parent or the other parent. And it was originally formed in a specific ancestor back up your tree somewhere and passed down to you through one of your 2 parents. Shared segments are where you and a match have the same segment, or you and a match have same overlapping segments. So a shared segment will come from a common ancestor. And I'll put in a plug again for my segmentology.org blog, where I cover a lot of this stuff in more detail. So here's sort of a graphic of a segment. It's a chunk, a block, a string, a piece, however you want to envision that. But in genetic genealogy, it's a long series of markers, which we call SNPs. And the segments come from your ancestors, as do the SNPs. So you can see there, I've marked out a big segment and a little segment. And this is, say, chromosome 5 or 6 or something like that. So here's one chromosome. It might be your mom's, it might be your dad's, and it just shows you graphically segments on there. So here are 4 terms that we need to know. Base
Jim,
pairs.
We don't see anything, Jim. We just see you talking.
I've got it.
Huh?
I see it.
I see it.
You see his shared screen? I
Yeah.
don't see his shared screen. I just see him talking.
I see it in the corner of my screen.
Huh?
Check how you're requesting the display on your screen.
I'm going to stop the share and start it again, okay?
Okay.
Click on view at the top of your screen.
Okay, I stopped that. Let me see here. I don't know if it's something I'm doing or not, but I'm going to do this and then go back here to sharing and screen number 2. I'm going to share screen number 2 and okay, can you see it now?
No.
Not yet.
Oh,
No.
no.
Nobody can see it?
No, I did
Not
before.
at all.
Share screen.
I saw it before.
Yeah.
Yeah,
Oh,
I saw it before.
Let me try it. Okay.
When
Okay.
I clicked it, it said host disabled participant screen sharing.
Escape
Well,
it.
that's different. That means not all of us can share our screen. It's what
Okay.
that means is it has the co-host, which is our speaker, and Joel can share
you.
their screens.
Thank you.
Mhm. Hi, cousin.
Summary.
Yeah, that's.
Ah.
Okay.
Almost.
Participants can now see your screen. Can you see a screen?
It's black now.
Nothing.
It's,
Okay, wait a minute. You try this.
Yes.
there,
Yes,
yeah.
there we go.
Yes,
Okay,
thank you.
okay. So that was the overview. Let me go back down here to wherever I was. Okay, so we're going to talk about these parts of your DNA. So you have base pairs. These are the individual molecules or building blocks. When you think of the double helix and the rungs on a ladder, they're the A rung on a ladder. And they're identified by A, C, T, or G, these nucleotides. And the test that we take measures 600 or 700,000, depending on which test you take, but a whole bunch of base pairs, which are called SNP, pronounced SNPs, single nucleotide polymorphisms. So SNPs is a whole lot easier mouthful than that. So that's what we measure, is these 600,000 points that are base pairs. So segments are relatively long strings of these SNPs, like 1,000 of them. Okay, they're long enough so that they can only come from one ancestor. A very short piece of your DNA may come from lots of different ancestors, might have that little piece that has some function that everybody needs. But when you get a long string of them together, they can only come from one ancestor. And that's the whole concept behind genetic genealogy. A chromosome is the largest part of our DNA, and it's formed from segments from one parent, which we often call a side, or the other. So you have two genomes. One genome is about 3 billion base pairs from one parent, 600,000 SNPs that are tested. And you get 23 chromosomes, 22 called autosomes, plus an X or a Y, depending on your boy or girl, type of thing. So actually, in our body, we actually have two genomes, 3 billion from one parent, 3 billion from the other parent. For a total of 46 chromosomes altogether. That's what makes a human being. Okay, so we measure segments three different ways. We can measure them by the base pairs and say that on a given segment, if you go from 45 million base pairs to 59 million base pairs, that's a segment of DNA. If all of that's on there, that's on chromosome 6, that's a segment. We can measure it by centimorgans, which is tied to the probability of a segment. And it's a very obtuse way of doing it. And there's a lookup table that's based on millions of observations that scientists have made. And so the companies look this up for us and tell us how many centimorgans are in a segment that we get. Okay, so let's say the segment's 15 centimorgans. And then the other way to measure it is the number of SNPs that were measured in that test. Which one, how many of the 600,000 SNPs are in a row that you get? So in this example that I'm using, there'll be 2,451 SNPs that were all in a row, and you got those. So there's no correlation between these. This isn't like Fahrenheit and centigrade or feet and meters where you can translate from one to the other, independent things. So let's look at how we might see these. Up in the top left is a hypothetical segment. Chromosome 6, this is a text version of this that you might see. From 45 million to 59 million, or we often abbreviate the 45 to 59 megabase pairs. You will see both terms used, base pairs and megabase pairs. 15 centimorgans and 2,451 SNPs. Graphically, if you share this segment with John Doe, the companies will tell you that show segment data. They'll show you John Doe's name. It's on chromosome 6, starts at 45, ends at 59, 15 centimorgans, 2,451 SNPs. Okay, that's a graphical form. That's what I put in a spreadsheet. You might see it in a chromosome browser or in DNA Painter. I don't know how many of y'all have used the DNA Painter, but from 45 to 49 on chromosome 6 would be about where this green block is, right here on chromosome 6. So that'd be a graphical way to look at it. All of these things are exactly the same, okay? They're just different ways of looking at it. Some people prefer to look at the graphical way. Some people, I like to use the spreadsheet way. Often in a text, you'll see it this way. Okay, so those are just segments. Now we're going to talk about your segments, your specific segments. You get your segments from your ancestors, and actually you get 23 chromosomes from each parent, and your parents got their DNA from their parents, et cetera, et cetera, et cetera. So each one of these chromosomes is going to have lots of segments in it from different ancestors, different levels of ancestors. So the biology of all of this is a parent, every human being has 46 chromosomes, and a parent combines their chromosome pairs, the chromosome 1s, the chromosome 2 chromosome 1s, 2 chromosome 2s, and passes 23 chromosomes to you. So from your dad, you'll get 23, and from your mom, you'll get 23. And these are made up of segments from your grandparents and the grandparents from their parents. So the grandparent segment's made up from their parents. So the recombination, 1/2 of your parents' autosomal DNA is passed to you. Exactly those first 22 chromosomes, you get exactly the same amount from mom and dad, and you get a little bit different in the other 2 chromosomes. And the crossover points are points between adjacent segments. And I'll show you this in a second. So recombination is how we get segments. And the recombination occurs at random, pretty much random crossover points. There are some places that have more crossover points in an area than others, but for the most part, for genetic genealogy, they're random. So recombination, one parent has 2 of each chromosome, and one from his mother and one from his father, and they recombine the 2 chromosomes into 2 new ones and pass one along to you. So here's how it goes. Here's the parent with 2 chromosome 5s, a maternal one and a paternal one. And they put in here 2 crossover points. And I'll talk about how we come to 2 crossover points, but there's 2 crossover points here between these 2, and these kind of merge together and cross over. So now you get blue, pink, blue, and pink, blue, pink. It's the same 2 chromosomes, but parts of them have been interchanged. And it's been recombined into 2, and one of them, this top one here, is the one we're going to pass along to the child, the blue, pink, blue. So here's the blue, pink, blue that's passed along to the child. And that's 1 chromosome from the parent with grandparent segments. This is an important piece to remember, that what your mother or father will pass to you is 1 chromosome. What am I on? Chromosome 5 or 6 here. And it'll have big chunks of DNA from your grandparents. In this case, 3 chunks alternating from your paternal grandfather to maternal grandmother to paternal grandfather. Okay, so there's few crossovers per generation. And I'll talk more about this in a second. The point is that it's not pureed. They don't put all of your DNA in a blender, grind it all up and spit it out into little bitty pieces. It comes to you in big chunks, okay? Some people think that it is pureed and you get exactly half. You don't get exactly half. Those crossover points are random. So at each and every generation, from parent to child, there's an average of about 34 crossover points per 23 chromosomes. It varies a little bit between mom and dad, but the companies generally use these averages. So that's an average of 1 crossover per 100 centimorgans. And in fact, that's how the centimorgan was defined. A morgan, 100 centimorgans, a morgan is where you can expect 1 chromosome, 1 crossover point per average. So the scientists have looked at all of our chromosomes and analyzed them out the gazump stump millions of times and determined what usually happens there. So on chromosome 1 is about 280 centimorgans long. It's almost 300 centimorgans. So usually you'd get 3 crossover points on there, sometimes 2, sometimes 4, maybe 1, but it's not 50 and it's not normally 0. Chromosome 5, the one we've been talking about, is about a 200 centimorgan chromosome. And so there's usually the 2 crossovers, and that's why I use 2. But there might be 0 or 1 or 3. Chromosome 21, when you get down to the smaller chromosomes, 70 centimorgans, it's usually 1, but it might be 0. What 0 means is that that segment was passed intact without any recombination. So if it's coming from a grandparent, it's going to be the whole chromosome is going to be from one grandparent or the other that your mother or father passes along to you. So the 0 means it's passed intact. And I'll talk more about this in a second. So parents pass along chromosomes from grandparents' DNA. The grandparents' segments that they pass along were made up from great-grandparents' DNA, and the great-grandparents' DNA came from the great-great-grandparents' DNA. So you get the picture here. So the concept here is that your DNA is a mosaic of segments from many ancestors. It's almost like an archaeological dig. The farther down you dig, the more you find from earlier ancestors there. Each generation, you'll get a set of segments that cover all of your DNA, all of your chromosomes. So every generation contributes 6 billion base pairs that you eventually got. Even if you go back 100 generations, you're going to have ancestors at that level, at the 100 generations back level, that contributed the 6 billion DNA that you got. They started passing them down. So here's another way to look at the same thing. This is a whole set of chromosome 5s with an average of 2 crossovers per generation. And your DNA is going to look different. This is just an example right here. And it's a way to look at it from the perspective of different generations. So this generation is your mother. Okay. I've used Onontoffel numbers here instead of names of my ancestors. 3 is an Onontoffel for your mother. And 7 would be her mother, and 6 is her father, 7's her mother. So this is sort of what we saw before. A whole chromosome from your mother would be divided by 2 crossover points here into segments from her grandmother, her grandfather, and her grandmother. But the grandfathers, the next generation back, there's probably 2 crossover points there, 1 here. I've put 1 here, just arbitrarily put 1 here and put 1 here. So the 7 is divided into 14 and 15. These are the names of ancestors, just pretend like. So this is the dad and this is the mom. And in this case right here, it's the mother and the father. And then this segment out here, there's only 2 crossover points, but there were 3 segments back here. So 2 of them got a crossover point in it and 1 did not. So this segment right here was passed intact from one great-grandfather to the grandfather to your mother to you. And then I've added 2 more crossover points here, and 2 more down here, right here, and over here. And what happens is you have 1 segment here, which is a whole chromosome. You have 3 segments here, 5 segments here, 7 segments here, 9 segments here. It adds 2 more segments each generation. The 2 crossover points create 2 more in number, but they're smaller now. And you can see that in general, all of them start getting smaller. Okay, so that's all. And this one over here, as it turns out, was passed for 4 generations in a row. That's what I call a sticky segment. I got some people in the genetic genealogy community hate me for calling it a sticky segment, but my point is to say, do you understand what I mean? That means that this segment was passed along intact without being subdivided. That's all.
Can I
It's
ask
just
you
my
a
way.
question about that? Sticky
Sure.
segment? So just so I understand it right, we'll say that that's starting with the grandfather, and he got it from his father, and he got it from his father,
Right.
for an example. So that means that if that's me, I got absolutely nothing from the wife of that grandfather or the wife of the great grandfather or the wife of that great great grandfather. There's
And
no
that
evidence.
on chromosome 5 only in this particular area,
Oh, just for this one chromosome.
right?
Yeah. Okay. All right. Thanks.
Okay. And for instance, let me show you here in this area right here. Here's one that has a 14 and this one here has a 14, two different ancestors here. And 15 is the 7 had a mother, had a father and a mother. And over here, the father was the one that passed the segment on this part of chromosome 5. Over here, this was subdivided into 2 parts. So you did get some of the other parent on this part, but not over on this part.
Right. Okay. Thanks.
So it's a mix and match. And you'll see that more in this picture right here. These are my great, great, great grandfathers. These are the same 5 generations, basically. This is a chart I did back in 2013. So 11 years ago, I did this chart that showed which parts I'd figured out. And there were some of them that I didn't know, but a lot of them that I did. So in chromosome 1, I had a father's DNA and my mother's DNA. And this shows which segments came from which ancestors. And if you do it right and you figure the whole thing out, every one of these, I have some little gaps in here, but for the most part, I've filled this all in. Okay. And this shows you the same thing. I don't know if it's going to show the same chromosome 5 as I had before, but that was just an example. But this shows these parts are everywhere. And another way to look at it is this way right here. So here's a tree that I have, my father's side and my mother's side over here. So all of these ancestors from halfway over here on the left-hand side, these ancestors are going to contribute segments that come down to my father's, the chromosome I got from my father. And these ancestors on the right-hand side are going to contribute the segments that come down to my mother's DNA. Okay. So again, there's several different ways to look at it, whichever way you're more comfortable with. I show it all these different ways just to make sure I've kind of covered different ways of looking at it. And on my blog post, I have some from 2015 and 16 near the beginning of my blog back there. I show the segments that you got from that's not the way to put it, from you up, some example of how it might look. I got no idea what yours really look like, but here's what they could potentially look like. And then I did the same thing, starting with the ancestors and working my way down with segments. And the answers are exactly the same. You know, your DNA is static. It's your DNA, and whatever you got going up and coming down, it's going to be the same in your ancestors and, more importantly, in you. Okay. And there's another one that talks about the number of crossovers per generation, which is an interesting, I could give a whole talk just on that. So here's the takeaways about your DNA. Each parent passes 23 chromosomes to you with about 57 grandparent segments in them. That's simple math. 23 chromosomes plus 34 crossover points equals 57 segments. So you're going to get roughly 57. If you wind up with 300, you've done something wrong. And if you wind up with 4, you've done something wrong. You ought to be a number, close to it might be 60 or 70, and it might be 30 or 40, but that's an order of magnitude. And then it subdivided 34 more segments for each generation going back. So you could add 34 and 57 and get 81. So you'd have 81 segments from your great-grandparents. And one of the tables in my blog post shows, taking this out to about 8th cousins, how many segments that you would get from them. So the ancestors grow exponentially, 2, 4, 8, 16, 32, 64. But the ancestors, the genetic ancestors that pass your DNA, not as much. And pretty soon, about 7 generations back, 8 generations back, you're going to come a time where one of your ancestors drops out of the whole picture. You will always get something from that person's spouse, but not from that person. So not all of your ancestors contribute to your DNA when you go back far enough. Now, if you're only working out to about 7th or 8th generations, sixth, seventh, and eighth. Basically, almost all of those are going to be in the picture, contributing DNA to you. Okay, so now we're going to talk about any particular questions about your segments and DNA segments. I'll go on to shared segments with matches.
Is this something maybe you're going to cover, but how do you distinguish between the maternal and the paternal?
I'll get to that.
Okay,
With shared
fine,
segments.
great, okay.
And actually, it's a good question because when you look at your DNA, when you look at the 600,000 SNPs and you look at a picture of your DNA, like the picture that I showed right here, you cannot look at your 600,000 pieces of DNA, SNPs in there, and tell where any one of these segments starts and stops by itself. There's no yard sign out there that says you're leaving your grandmother and you're moving into your grandfather, you know, along the way, along one of these lines here. There's nothing that tells you where these points are. You have to have shared matches to do that. Okay. So that leads me to shared matches, shared DNA segments. Okay. Segments that you share with your matches. So there's an important concept here. It's going to be on the quiz at the end.
Uh-oh.
I'm teasing. The ancestral segment that you have in your body was created by biology. It's in your body, and all of your segments are true segments. Okay. A shared segment is created by a computer. Okay. So the computer looks at your 600,000 SNPs and looks at the other person's 600,000 SNPs and tries to find a long string of matching SNPs, long enough that the scientists have determined can only come from one ancestor. And that would be the common ancestor. Okay. So that's where you and your match overlap your segments. So here's an example of that, the ancestral segment that you got from a common ancestor. And this is the matches segment that they got from the same ancestor. And it would be absolutely phenomenally impossible for you and your match, who comes down through a different child through random DNA, to get exactly the same segment that you got. So their segment's going to look a little different than yours is. And the only time you see it is when there's enough of it down here to be a shared segment that shows up when the company compares them. And when they say you have this shared segment, that means that you share part of the matches segment and part of your segment is the same. Okay. So here's where you have a whole bunch of them. So here's the segment that you got, say, from a common ancestor, and here's a bunch of ancestral segments, the same ancestor that your matches had, let's just say. And so each of these matches, you can draw a vertical line down on yours and on theirs and yours. And these are the shared segments that would be reported by the companies, these green things. This one down here probably would not be reported because this little piece of green overlap with you is not significant enough to be called a shared segment. It's not a long enough segment. So match 5 would be out of the picture and you would get 4 matches here, these 4 matches. So these 4 matches here would form a group, and they'd all be the same. Are they all on the same maternal or paternal chromosome? There's the rub. Maybe, maybe not. This could be a match who matches you on your father's side. If this is your father's segment you got from your father, and maybe they matched you there, and maybe here, but maybe this one right here was a match to your mother's DNA. You don't know. So you have to figure that out. So that was a good question, Sydney. So if they are on the same chromosome, you have a triangulated group. If we've got time, I'll talk more about these triangulated groups because that's an important concept. The triangulated group means they all have the same ancestor. Okay. So one other concept that we have to have here is identical by descent and identical by chance. You could read this instead of these fancy terms, identical by true or false is what it means. So identical by descent means a shared segment from the same ancestor to you and to the match. Identical by chance It's called a shared segment because the computer says you have the same SNPs in that area, but one or both of you did not get that segment from an ancestor. It might have been it took a little piece of your mother's, a little piece of your father's, a little piece of your mother's, and stitched them all together, and it looked like to the computer that it was a match, but it wasn't really. So that's actually a false match. And this only occurs under 15 centimorgans. So if you only use 15 or more centimorgans, you don't have to worry about this issue. About 25% of your matches under 15 centimorgans are going to be false. Okay. When you get down to 7 centimorgans, about half of them are false. And okay. So they both look the same on a chromosome browser or DNA painter. You'd look and you'd say, hey, here's a shared segment. You can't tell just by looking at that if it's below 15 centimorgans, whether it's a true segment or a false match. So another concept here is the most recent common ancestor is usually a couple, okay? A husband and wife team. You descend from one child, that's your ancestor of the MCRA couple, and the match segment is from a different child, which is their ancestor. And so the DNA that you share with the match comes from either the husband or the wife, not both. It comes from one or the other, okay? At this point, you don't know which one it is. All you know is that you have this couple that it came from. Now, if you have, a man or a woman that has two spouses, and one is from one spouse and one is from the other, then the DNA came from the common one. Okay, has to have come from the common spouse there. But if you have a standard husband and wife and they had all these children, you can't tell which one it's from just by looking at that data. There's other ways you can figure it out. So large, let's see, am I doing this right? Yep. So the large CMs are close relationships. They're easier to work with. I recommend that you start with your largest ones and work down. Smaller CMs are necessary to determine MRCAs beyond fourth cousins. It depends on your objectives. And I recommend you start with your closest ones and work your way back as you want. The relationships are estimated by the shared CMs through many observations, and use the shared CM project and the DNA painter to get these shared matches out to eighth cousin. I'll show you this chart next. DNA is random and not precise, so there's wide ranges of possibilities. There's a whole range of things that could be a third cousin, a fourth cousin, or a fifth cousin. See, so here's I hope y'all have seen this chart before. This is the Blaine Bettinger's shared CM project. And actually he's coming out with version 5 soon, he says. It's coming out. So this will show you a third cousin is 73 average, but it could range from 0 to 234 centimorgans. Okay. And there's lots of other relationships in here that could be in that range. That could be 73 centimorgans. A lot of them. So I just put in a plug here for small segments. I have a contest going on with most of the other genetic genealogists. Don't be afraid of small segments, but be careful with them, okay? Most shared segments below 7 centimorgans are false. I don't recommend anybody going below that unless you're really experienced on how to do it. Some matches with small segments may have good genealogies. A lot of your true cousins will not share DNA with you. About 50% of your fourth cousins won't share DNA with you. 50% will share DNA with you. But what are those fourth cousins that don't share DNA with you? Are they chopped liver? No, they have good trees. They might have Bibles. They might have pictures. They might have some pretty good information for you. So anyway, 7 to 15 are roughly 75% true. And a lot of cousins may share these. So the important point here is that if you have a 9 centimorgan segment with a 7th cousin, that is not proof by itself. Please don't use that as a proof statement by itself. You need to have roughly 8 cousins that all have the same segment and go back to the same ancestor, that is then strong proof. Okay, you need to have the genealogy in there. So segment takeaways. Your segments are from your ancestors and they're true. You measure the segments with base pairs, centimorgans, or SNPs. The shared segments are from computers and all of them over 15 centimorgans are true. And you can see the shared segments in a browser, on DNA Painter, in spreadsheets, anywhere you can display these. And some of the smaller ones may be false, but you need some smaller ones. The genealogy is okay, even if the segment is not there. You don't have to have DNA with somebody for them to be your cousin. So the two issues that we find is a shared DNA segment on a maternal or paternal chromosome, and you need to resolve that with genealogy usually. So if you if the shared match is in here, if you notice that somebody, you're not really sure whether the segment is on one side or the other, you can look at their shared matches, and if you find several of those shared matches are known cousins to you, that's the same side you're going to be on. Okay, so you can figure it out that way. Under 15 centimorgans, you need to figure out, are they true or false? And you resolve that with known relatives too, or grouping methods. And I'll talk about grouping methods. I think we're going to have a little bit of time to do that. And decide whether they are true segments or not. If you have a big knot of these, a big group of them, and you can figure out the relationships, and you can be more confident that the segments are true. And if you stay above 15 centimorgans, you don't have to worry about this at all. Okay, so time for questions and answers. Unmute yourself and you can ask anything you want here about segments. Everybody's got it. Should I start the quiz?
What if you're, say, a fourth cousin from one ancestor and a sixth cousin from another ancestor and a ninth cousin from yet another ancestor, and you have matches, a match shares some of that mess.
Right. Okay. That's entirely possible, and that's actually a good thing. And it's what I call walking the ancestor back. So if you have these segments that they share, and you have a second cousin, and then a third cousin shares that same segment on the same line, same ancestral line, and a fifth cousin and a seventh cousin, that's very, very strong evidence. That's the way it's supposed to work. That's showing you that the DNA is coming from those more distant ancestors. So if you have a third cousin, you don't know whether that DNA is coming from the mother or the father in that third cousin couple, okay? But if you go back to the fourth cousin level and you have, you know, the same segment back to the fourth cousin, you now know which one of the two parents that went through at the third cousin level. You'll never know what the terminal one is, the most distant one, but you'll know what that one is. Does that answer your question, Alan?
Yeah.
Sort of.
And so I kind of wonder, what's the computer gonna predict?
That's the shared CM project.
Well, yeah. What, is it gonna say, oh, you look really good? You look like a second cousin, but you're really not. You're fourth cousins twice or something like that.
That can happen because those ranges in there overlap a lot. And so if you share 20 centimorgans with somebody, you could be a first cousin, second cousin, third cousin, fourth cousin, and fifth cousin with that amount of DNA. They're all legitimate amounts. There's no narrow range that all the fourth cousins have to fit into. That's just because the DNA is so random coming down and different sizes come down. It's almost like the Mickey Mouse Club, anything can happen day kind of thing. Or sometimes I use the pachinko machine thing where the little balls just come down on a pachinko machine. You don't know where they're going to land. So don't try to pin the tail on the donkey. Don't try to take one number out of the CM chart and say this person has to be a second cousin once removed. It doesn't work that way. Now I have recently, I was looking at Pro Tools, which is a new tool that Ancestry has, and I had an unknown match there, but it turned out I found through Pro Tools her father, and her father was born the same year I was born. So that means that she and I are probably first cousins, are probably cousins once removed. We might be first cousin, second cousin, third cousin, but we're a generation removed because her father and I were born the same year. Okay, so she's one generation away from me. 99 times out of 100, that's going to be a once removed cousinship. It might be a second, a third, a fourth. As it turns out, she shared 192 centimers with me. So I looked that up, and 53% of the time, a second cousin once removed is in that category. Over half the time, it would be a second cousin once removed. And to get to a third cousin once removed, I'd have to go down to like a 3% chance. It could be that 3% chance, 3 out of 100, but probably what we say often is if you hear hoofbeats and you're in the United States, think horses. It could be zebras, but probably it's horses. So a lot of this is that sort of an analogy.
I think part of what I'm hearing is that the DNA and the genealogy are sort of mutually confirming. I mean, you can have problems with your genealogy. You may have mistakes in there, which all of us, I'm sure, have seen. And the same with the DNA. There's some uncertainties involved, but if you can get them to line up, then you have a lot more certainty about what the relationships are.
There's two kinds of consensus, and one of them is a genealogy consensus where you got 5 or 6 or 7 or 8 people that all have that same ancestor genealogy wise. And that means that if it came from wide cousins, not a whole bunch of brothers and sisters, going up, but from different directions, they all come in and say, hey, I have found that person in my tree. Well, all of those people probably weren't wrong. Maybe they all copied from each other. You don't know. You can't be 100% sure. But if they all arrived at it from different directions and came up with that, that's genealogy triangulation. If they all shared the same segment, that's very powerful to have everybody having the same segment, because the same segment, and they share that same segment with each other. That had to come from one ancestor. And so when you combine those two, if you can get the genealogy and get the consensus between, they think the genealogy is this and they have the same segment, you have a very powerful proof argument there. Okay, it's hard to amass that much data, and you've got to really dig for it. That's why we spend so much time on genetic genealogy. But that's where it is. And it's a whole lot easier when you're working with first cousins, second cousins, third cousins. It gets harder as you move out. But as you move out, if you have this base of known second cousins and third cousins, then when you go out to the fourth cousin level, you're only choosing between 2 people, the parents at the third cousin level. So if you have this group, you only have 2 choices there. You don't have to figure out the whole universe. It's just if you're in that cluster or in that group going back, and particularly if they have a little bit smaller CM than the rest of them do, it's probably back another generation. But it can only be the mother or father of the rest of the people that are in that group going back.
Jim, before we go further with this, I just want to double check to see if other members of the gig have questions on the first part of Jim's presentation.
I could throw another one out.
You've overwhelmed us all.
Okay. Well, I'm going
Try
to
to
go on
absorb
to the
it.
grouping part here. Bonus round.
All right.
Cut me off if I go too long here.
Did you
So
have
we're going to
something,
talk
Alan?
about grouping. Okay. So there's 2 grouping methods that are in wide use and that I like a lot. One is segment triangulation, which I talk a lot about in my blog and how I really got started with this whole thing. It leads to triangulated groups, TGs, I abbreviate these with. So that's a group of overlapping segments on the same side or parent, okay? So you got to work a little bit to make sure that they meet both of these requirements, overlapping and on the same side on one chromosome. You don't want them to overlap when some of them are on your mom's side and some are on your dad's side. You want them to be on the same side. So your segment is from a specific ancestor out to an MRCA, and the segment is on one ancestral line out to the MRCA. So this piece of DNA segment is in all of these ancestors out to the MRCA. It started with this MRCA, the father or the mother, down to a child, to the child, to the child, to the child, to you. And that same segment, or it could have started as a larger segment. Actually, at the MRCA, it started as a whole chromosome going down to the child, and then it got smaller and smaller and smaller. So the segment that you got was somewhere in that segment that the MRCA passed down. Okay. The second clustering method is clustering. Clustering is shared matches, and this is the case where matches are on each other's shared match list. So you have your list of matches. I got 90,000 matches at Ancestry, and you have 90,000 matches at Ancestry. And they look at those two lists and they pick out all the matches in there that are the same. That's your shared match list. You both have those matches on your list. Okay. So then if you pick one of those shared matches and look at their shared matches and then say, okay, what's on all three of your lists, or four matches, what's on all four of your lists? And once you have a consensus, you might wind up with, say, 10 matches that are in a group that 9 out of the 10 always match 9 out of the other 10, but it might be a different part of the 10. But you have a consensus. They're all tied together. So these tend to have the same ancestor when that happens. Okay. It's not guaranteed, but it happens over 90% of the time. Or 90%, it'll happen 100% of the time when you get a good solid big cluster, and almost all of the matches in there will have that same ancestor. Maybe one ancestor higher, one ancestor lower, but you get the point. You're out the same branch of the tree. So these are both very powerful groups. This even picks up matches that have no trees or NPEs. It might be NPEs or brick walls to you, beyond your brick walls. Okay. These matches will show up in clusters. Okay. Even though you don't know how you're related, the DNA is telling you. The DNA is like a magnet pulling these people together with their common ancestors. Okay, so I'm going to talk about segment triangulation here a little bit. There's lots more at segmentology.org. So every DNA segment is either IBD, is either true or false, and it's from a common ancestor or not. So all the IBDs are from, the true ones are from a common ancestor, the false ones are not. If it's true, then it came from a common ancestor. It must be on a maternal or paternal side. So all shared segments are either on your maternal side on a chromosome, say 6, or on your father's side on chromosome 6, or neither. And if you can't match it up with somebody else, then cull it out. And these will all be under 15 centimorgans, as I've explained before. So I have long since, 10 years ago, I've gone through every one of my segments and put them into these categories. Okay. So the rule for triangulation, 3 significantly different overlapping shared segments. That means from cousins. Okay. It's the same location, overlapping location on a chromosome. It's usually you and 2 matches, which are cousins. These 2 matches aren't brother and sister or father and son. They're cousins, and they have overlapping segments. By having that separation between these 2, you're making sure you're not getting the same thing from both of them. You're getting these different. And those 2 matches match each other on that segment. Or if you can figure out that these 2 matches are on your paternal side or maternal side, which often you can figure that out. Okay. then you have, that's the triangulation rule, you have that. That ensures a true segment from an ancestor. Very powerful information. So the shared segment should, these are some of the fine print here where people try to get around the rule because they have some goal that they're trying to reach and they try to bend the rule. So shared segments should overlap at least 7 centimorgans. So don't go to GEDmatch and say, well, I found a bunch of 5 centimorgan segments or 3 centimorgan segments that all match. Don't do that. Matches must be by separated cousins. Do not form a triangulation with 3 siblings. Once formed, however, once you have a triangulated group, you can add in all those other cousins. You can add the 3 siblings in. You can add in your brother and sister, your aunt, your uncle, to this triangulated group if they have overlapping segments in there. Segments should match most others, maybe not all of them, but most of them in there. You'll see segments on a spreadsheet that kind of just walk down. I'll show you a picture of it here in a minute. And so most false segments will not triangulate. They're not truly from common ancestors, so they won't triangulate. And so you call them out of the picture. So the process, again, this is in my segmentology. I go into this in several segmentology blog posts, but you collect your segments, arrange them by sorting by chromosome and start. You compare overlapping segments, a company at a time. And then you group these segments into triangulated groups, or you toss them out as being false. And the end result is triangulated groups. So let's see how this looks. So you're going to start with all of these segments right here. They look like they all overlap. They do. They sort of overlap each other, okay? And they're all on one chromosome, okay? Chromosome 6. This is my 45 to 69 section in there. So when you do the grouping, it turns out that these 4 right here all grouped together and these 5 here all grouped together. They matched each other or they were on the same side, okay? You label them A and B. And now you can take, like we did before, here was that green one that came down on that chromosome 6, and then the purple one is going to be right here. You still don't know if it's mother or father, and you figure that out in the next step, okay? So the next step, 5th step, is assign these things to your mom or your dad. So you have to use genealogy to do that. Maybe you could use ethnicity. I have a stepson that has 50% English ancestry and 50% Ashkenazi Jewish. So it's pretty easy to look at all of their shared matches and tell which ones are Jewish and which ones are English. I can pretty much tell the group, the 2 sides there. And the triangulated groups on one side, on your, say, your father's chromosome, will be adjacent to each other, heel and toe. And your goal here is to fill and cover an entire chromosome from one side to the other, as you saw in the colorful picture I showed you before. So here's a partial fill of chromosome 6. This is our green and purple ones that you saw. Here's some other ones that I had found, type of thing. And you can see the crossover points here where one starts and one stops. You can tell that from these triangulated groups, which we see only because, like this green and yellow, these right here have a whole bunch of SNPs in a row with a bunch of matches. And then this one right here has a whole bunch of SNPs in a row from a matches. And we can tell where the SNPs sort of start and stop. So that's a crossover point right there. That's how you determine that's the only way you can do crossover points. That point is nothing special in your DNA. It's a difference between an A right here and a G right here, but you don't know which ones it is. Okay. So these are now on maternal or paternal chromosomes, and you can get that chart that I showed before. And now you revert back to the genealogy work and you figure out who the most recent common ancestor is for that. Walking it back is a good way. Walk the ancestor back along the ancestral line. I'm not going to go into this in great depth right here. So a triangulated group is really 2 things. It's a group of matches. It's a whole bunch of matches that are cousins from a common ancestor, and it might be second, third, fourth, fifth cousins all mixed in here, but they all come from one ancestor or one MRCA, as it were. This is powerful information. There should be a lot of synergy here. You ought to be able to contact these matches and say, hey, we're all in a group together. Let's work on this. And you get no answers back from anybody. But that's the sad part about this whole thing is very few people really want to help with that. But it's also a group of segments of your DNA. And it's DNA from a specific ancestor back in the MRCA, one of the other mom and dad. So that's equivalent to phased DNA. And I haven't talked about phased DNA, but that just means it's the correct ACTG lineup on that side. It's like a haplotype. It's like you've heard of the Y haplotypes and the mitochondrial haplotype. This is almost like an autosomal DNA haplotype. And it's like a laser pointer, which only goes to the one ancestor. So it's a segment of DNA and a pure segment of DNA, which you share, parts of it you share with other matches. Okay, takeaways is you group all your segments and all your matches. Yeah, I went through 10 years ago. I had all my matches and all my segments arrayed by triangulated groups and on maternal side, paternal side, and a whole bunch of them in the lower levels that were culled out. And this was a great help getting rid of these people because they didn't really share a common ancestor with me. They might have been an ancestor that just didn't share any DNA with me at all and still was a cousin, but I chose not to fiddle with them. It's a laser focus on one line, and there's a synergy you wish there were. And these triangulated groups can see through a brick wall. So I have several cases of a whole bunch of third cousins all match, and then there's no other fourth cousins or fifth cousins in that triangulated group that match. So I went, the third cousins I knew about, the other people that I didn't know about, I went and looked at those trees, and they had a consensus of one surname. Well, that was the surname that would have been on the other side of the MRCA. And I've done that a couple of times now, figured out the other side of a brick wall because the DNA goes through the brick wall and it eliminates most of your bad segments. Okay. Clustering, this is a grouping process based on shared matches. I think I've talked about this. Is a lot of beneficial features because they form on ancestors and they cluster very close, very parallel to triangulated groups. I've actually done the research on this and done all of my matches at Family Tree DNA as triangulated groups and in clusters. And with a little bit of manipulation, clusters aren't quite as precise, but I could get them to align pretty close. So you can see the blog for a lot more on that. So the clustering methods, there are the Leeds method. This is where you basically do 4 columns and 4 colors, and you get your 4 grandparents with your top most matches from 90 to 400 CMs. Genetic Affairs has a fee. You can subscribe to that, and you can adjust the clusters. And DNA GEDCOM client, this is the one that I use most of the time. There's I think it's $50 a year to belong to that. Some of these have been offline for a while now with cease and desist orders. DNA GEDCOM client is now coming back online with Ancestry, which is the one that I want to use it. Clustering works best with Ancestry because you don't have segment data. Where you have segment data, I would recommend using triangulated groups. Where you don't have segment data, I would use these clustering methods. MyHeritage, you can do this, and at GEDmatch, you can do this. This is a tier 1 free. If you belong to Genetic Affairs, you can do it there. I don't know if I have, some examples. This is what it looks like at MyHeritage, 21 clusters. And each one of these would go back to one common ancestor. Here it is based on the Genetic Affairs at GEDmatch. This was 435 kits, 110 clusters. This is just a portion of them. This is the DNA GEDCOM client clustering method. And I adjusted the amount. So I got 15 clusters there, and they align pretty well with my 16 ancestors at one level with one cluster for each one of the ancestors there. So clustering benefits, it groups the matches. There's a pointer to the MRCA, which is a powerful focus. Synergy, if you can get the matches involved. Brick walls, the matches, if you have a brick wall, let the matches tell you who your ancestor is on the other side of that brick wall if they're in a cluster. It's a mechanical process to point and click, or you can do manual clustering. It reduces the number of ancestors in play. You can use it to build out a chromosome map to extend your MRCAs, and a tool to help yourself and your matches. Whenever I find out something on one of these, I try to tell my matches, hoping they'll respond. Few do. Clusters form on ancestors. So that's the bottom line there. So that's the end of the formal presentation. Any questions on anything about genetic genealogy that you want to ask me?
I'm overwhelmed.
Yeah. Jim, I have a strategy question. I had undertaken an effort to find some matches to confirm a common ancestor about whom I knew very little. We knew that he was first found in Maryland in 1812. He said his parents were in Virginia. So I undertook an analysis of first cousin maternal, some cousins on the paternal side, and I couldn't find anything that would have the proper surname. I found surnames in Italy. I had surnames in New York, and a lot of people didn't have enough trees to even know if we shared a big match, where it might have come from. So strategy-wise, my question is, it's been probably 6 or 7 years. Should I wait a few more years to see if a lot more people have taken a test and worked on their tree for me to then look again for matches? And
No, I'd look every day.
every day.
I'd look
Oh
every
my
day.
gosh.
Well,
Take
let
some
me
Geritol.
let me say that when the genetic genealogy started in 2010, the autosomal DNA, and 3 companies were into it by, I think Ancestry joined in 2012 about, and the number of people that signed up doubled every year for about 6 or 7 years. It was just phenomenal. Each year we'd report on it, and it would be twice the number it was the year before that. It's kind of leveling out now. You do get a lot more. I get hundreds more every month from Ancestry. I get 5 more at 23andMe, every month or so. So more come in. But generally, are you tested at Ancestry?
Yes, but we did it all in family tree DNA, the 5 of us that I tried to use in that quest.
Yeah, I would use, okay, here's the deal. At Family Tree DNA and MyHeritage and 23andMe and GEDmatch, you can get segment data and do triangulated groups and form triangulated groups and try to use those as tools to push back. But all of those companies, in my opinion, have very poor genealogy tools. 23andMe doesn't even allow you to use trees anymore. Family Tree DNA has terrible trees. And GEDmatch lets you put in a GEDCOM, and maybe 1% of the people do it. Terrible on the genealogy side, good because they show you the segments. You go to Ancestry and you get all kinds of trees. You get lots and lots of trees. I got 90,000 matches there. And yeah, there's a bunch of them that don't have trees. I don't focus on what doesn't work. I work on what does work. So I look at the ones that do have trees. Okay. But they don't have segment data, so I'm stuck without the segment data, and I have to rely on shared segments. And particularly with the pro tools, I just put out a blog post today talking about pro tools. Costs you $10 a month. It's well worth $10. Spend $10 and sign up for 1 month. You can sign up for it today and unsubscribe tomorrow, and they'll still give it to you for a month. They'll use it for a month. And what that tells you is how your matches are related to each other. So I'm
Should
looking
I
at some
upload-
unknown match that I have, and I look down the list and I look down the list and I look down the list, and finally, here's somebody that shares enough DNA to be their son or daughter, and that person has a tree. Well,
Okay.
holy cow, now I know exactly who that is. You know, it's the parent in the tree that the other person showed. So just amazing what we're finding using this Pro Tool. So I recommend that to everybody.
Okay. Well, thank
Look at
you.
my blog post today. But back to your question. I have in my blog post, if you go to the top line in the header row in there, there's an outline of it. And scroll down, there's a place there that's called bioancestors. There's 2 or 3 ways to do that. But basically, the way to find a bioancestor is through groups, shared match groups, which you will find largely at Ancestry. And you don't have to have all these other people involved in it. If you're at Ancestry, you can find this person. You can
Okay.
find the tree by looking at people that get up close to that, but not through it. You know, you want to form the group. Have you ever used the Leeds method? Figured
No,
out your
not yet.
okay. Leeds method is you take your top matches between 90 and 400 centimorgans. You do 4 columns, and you list all the matches down there, and then you start with the first one, the top one, and you say which of the other matches do they match, and you color those blue, and the next one you color yellow that all match each other, and green and brown, whatever. You wind up with 4 colors, and those 4 colors are invariably your 4 grandparents. Okay, because you're only using first and second cousin matches in that area.
Right.
So then you pick the group that is then on the grandparent side that you're looking for.
Right.
Okay, and then you look at their shared matches, which are largely going to be still on that same grandparent, but farther back. Okay, and you start looking at those and just jot. I've done this in an afternoon in a couple of hours. You just start jotting down what the surnames are for those ancestors, and pretty soon Rumpelstiltskin comes out 4 times, and you look at it and you say, well, holy cow, this is the same Rumpelstiltskin in all 4 trees. You've got the tree. That's your ancestor, is Robert Rumpelstiltskin, because
All right.
these people that are second cousins or third cousins to you have them, you have a consensus of who that is. I've done this dozens of times now with different people. Some of them are hard. If you have an ancestor that was on the wagon train and parents died and they got left by the side of the road, and somebody picked them up and raised them as their own, and there's no record or nothing. Sometimes those are hard. Sometimes the Martians brought them down and put them under a rock somewhere, and that's all you've got to work with. But let me tell you this, you have to be a believer. That person had 2 parents, a mother and a father, and those 2 parents had 4 other parents, ancestors, who had 8. And those 8 people and the 4 and probably the 2 parents were living, breathing human beings who did leave records and are out there and they had descendants. Even if the 2 parents had no other descendants, the 4 grandparents certainly had descendants, and the 8 great grandparents had descendants who came down and are your matches. Believe your matches are there, going back to those people. And so you have to dig in, but a bottle of wine and a couple of friends, we're sitting around the table, I can figure this out in an afternoon, usually.
All right, you're on.
Bring the wine. Yeah.
No problem.
Okay. And it's
Other
fun.
questions for Jim?
I have a question. This is Donna.
Okay, Don.
I have only one first cousin, and I was the one who got him to test. There are no other first cousins anywhere on any of the sites.
Okay.
They just didn't test. I have almost all European ancestors. It doesn't do me any good to pay attention to surnames. They change all the time, and they're very, Swanson, Jensen, that type. I have Danes and Swedes, and for some reason I have Norwegians, but I can't figure out why I connect to Norway or how. But anyway, that's another question. But so in Ancestry, I encourage people to to send their DNA or to do the DNA test at Ancestry and then share those results with the other sites. But especially if you
That's
have
a good method, yeah.
especially if you have mostly European, Ancestry is useless. Ancestry is good for people who have lots of history in the United States, but I don't go back hardly any distance
Upload
at
for
all.
free to MyHeritage, which does have the most European
Yeah,
ancestry.
exactly. And so I tested my cousin, and he and I share 32 DNA segments. And we have 759 common matches. Almost all of those 759 are triangulated. Is that usual for first cousins?
Sure.
Oh, okay. Okay.
You said all 759 are what? Are
759, maybe 90% are triangle.
they triangulate on one
Yeah,
one
you know how
segment?
the report comes back that you have these people and then the little marking shows that they're triangulation.
This is at MyHeritage.
At MyHeritage, yes.
Okay, so they have the little, you have a triangulated group symbol, but that
Yep,
symbol could be on any one of the 22 chromosomes.
right, yeah, I have to go to look at each one, but I'm just saying is it, I don't
Sure.
have that many with others, so I wondered if it had to do with him being a first cousin.
Okay, let me tell you this, Donna.
Mhm.
When I did my triangulated groups, I used 7 centimores in my lower level, and I use about 10 now. But I have 372 triangulated groups figured out. 372 that cover 99.9% of all my DNA. Out of 372, that means, let's just round it up to 400 to make it easy. That means that I have an average of about 200 on my dad's side and 200 on my mom's side. If I go to my grandparents, I would have 100 of these segments that came down through each one of my 4 grandparents. And 50 of these triangulated groups would come down on average from each of my great grandparents. Those segments had to come down. So having a whole bunch of triangulated groups with a first cousin is not a problem. That's actually good news because it gives you a lot of different avenues, a lot of different ways back. Now, the segments that you have with your first cousin are going to go back to different second cousins, third cousins, and fourth cousins. They will branch out just like the tree does from the two of you share a grandparent at the first cousin, as a second cousin, whatever it is. Those segments are going to go back on randomly the ancestors of the common ancestors that you share. Does that make sense to you?
Yes, and several of his nieces and nephews have tested, so I have that, first cousin once removed, sometimes second cousin matches.
Yeah. That's all reinforcing evidence, yes.
But the problem is that well, luckily for me, his paternal is my paternal line, right? And that's Denmark. Both my Danish grandparents, my
So
father's
you've done the
parents.
Y-DNA for them?
No, because
Oh.
I have no, it doesn't, there's no point in doing Y-DNA if you don't have a name that continues, right?
Well,
there's the name
yes.
changes all the time.
Y-DNA is going to
problem.
give you matches that are on that line, which may help you with the different spellings and the different names going back.
Uh-huh. But the other problem is it seems that has to be a straight paternal line, and
Yes.
it gets interrupted too much. I'm trying to find a missing great-great-grandfather, and but it's through a great-grandmother, so it
It's
gets
not on
broken
an
up.
all paternal line. Okay.
Yeah, I don't have an all paternal
Okay,
line.
well, do the leads method and get your 4 groups, and then take the one group back that goes, and that group is 1/4 of your DNA. So roughly 1/4 of all your matches will be shared matches at a lower level than the 90 centimorgans that you used on the leads method.
Yeah, I think that what we forget though is it all depends on who tests, right? And
Yes,
and my mother's line, I mean, I don't know, they're just not testing.
Okay, but Donna, I can't fix that part, and I
I
can't tell
know,
you what
I
to
know, but I'm
do.
just
I
warning
have
people.
no
I'm just
hints
wa-
or help
I'm
on
just
how to
warning
get
people.
how to get people to talk to you or take the tests. I can tell you how to use the processes to get the most out of what you have. So my main thinking is on what you can do and not to focus on what you can't do.
Right, but I'm just saying, there's that one section I can't really do anything with, so.
Well, I can't either.
But unfortunately, I see in my mind, when I try to do the triangulation, and then I get all these people that don't look like they belong to my cousin, I think that there's a mix-up between paternal and maternal on the same segment. And I don't understand how they can
You have to be able to
separate that.
separate it between your maternal and paternal sides. As
But-
I explained in the triangulated group and look at my blog post, you have to be able to say these people match each other or you're sure they're on the same side. One of the two things. It's a two-step process. You
But
have to
that's a
have both steps.
that's a genealogy question, right?
Yes.
Because okay, so what I'm saying is that my heritage tells me that all these people are triangulated, and I think it's wrong because it doesn't make sense.
No, no. The mechanics of figuring out a triangulated group at MyHeritage is 99.9% correct.
How do they figure out the paternal maternal?
They
That's what I
don't.
can't figure-
They don't. They don't know if it's maternal or paternal. They know that it's a triangulated group. If
Well, I don't see how they can know it's a triangulated group. All they can say is that all three people match at one place on a chromosome, but that could be a mix between.
okay, wait a minute. You need to, okay, take that one place where they match. Now add another person into that triangulated group and see if they triangulate.
No, I
You're
said
allowed
we
to
have.
add people to it. So you could have 3 or 4. You can have, I think, up to 7 people in a triangulated group.
Oh, okay. I'll try that.
Okay,
Thank you. That gives me a little
Sure.
more to work on.
I have a couple of questions.
sure, Sydney.
Jim, where would you start? I mean, I have a pretty robust genealogy tree. So,
Uh-huh.
I mean, I have like a brother, an uncle, and a lot of cousins. Do I start like with a painter? Do I start just with my brother? And that's one kind of question, sort of go layer by layer within the grandparents, great grandparents.
Right.
And then the other question is, you had a lot of examples with chromosome 5 and 6. Was there a reason for that?
Well, the reason for using chromosome 5 and 6 is that in that area, you got 2 crossovers, and it's easy to do 2 crossovers and try to explain a 2/3 of a crossovers or sometimes 1 and 4. I just wanted to have something that was simple that would work. But and if you're going to do triangulation, I would start with chromosome 5 or 6. If you start with chromosome 1 has the tips of chromosome 1, which are harder than other places to triangulate. They got a lot of people jammed into a short space on the 2 tips. So when people just start with chromosome 1 and work down, they get bogged down and very frustrated right off the bat, where it's a whole lot easier to start with a chromosome like 5 or even a chromosome like 10 that's smaller and fewer segments involved in it until you get your feet wet and you kind of understand what you're doing there. The other thing I'd have to ask you is, where did you test and what are your objectives?
Family tree, DNA, and ancestry.
Okay.
And I think I was just
Actually,
I kind of like to where I'm fairly confident going out to the 4th generation for cousins, second cousins, etc., 4th cousins. I don't have much confidence going beyond that. And some of it is in Europe, and so it's harder to.
Yeah, it is. My recommendation is to start with one person, yourself, and try to work out what you can with yourself. You can use the other tests to tell what side people are on. If you not with a brother or sister, but with an aunt or an uncle, you can tell which side this is on. And at Ancestry, they pretty much give you two sides, right?
Right, right.
So you
right.
know your maternal and paternal. Ancestry, maternal and paternal sides out through fourth cousins, maybe even the fifth cousin, is pretty darn accurate in my estimation. And do you have a lot of through lines?
I haven't spent much time on that, yeah.
Oh, look at those. Those are, they're clues, but in my opinion, out through fourth cousins and even fifth cousins, they are 95% correct. That's a high percentage of correctness when you're talking about not knowing much about your tree at all. When
Uh-huh.
Ancestry gives you that stuff that's going to be 95% correct, it doesn't take much to go through, particularly first, second, third, and fourth cousins, to look in census records and stuff like that and sort of validate what they've done. But they, off to the right-hand side of your screen, they will have why they think this tree is correct. And you can look at a bunch of other people that have already done the research and see if their research looks correct to you. So
Okay.
that's my recommendation, is to try to build your tree back. One thing that I do personally is that when I find a cousin at Ancestry that I believe is correct, I will enter that person, I will add that person in my tree. I will enter the line of descent from our common ancestor down to that person and include that person. That person is living and will not show up in anybody else's tree. It'll show up in your tree, but not in anybody else's tree. So you're not giving away something
Mhm,
because they can't see it. But
mhm.
I put them in there, and when I do that, then that helps me when somebody else from that family joins.
Okay,
So
thank you.
I recommend working backwards from your closest matches back, try to figure them out.
Other questions for Jim?
Sure, I have one.
All right, Alan.
Say, there'll be times when I find a tree that smells pretty good. And I sure wish that person, I can't tell if they took a DNA test or not. And I'll email them, and the big thing is this, how do you, what are the resistances, the reasons for not taking a test if someone were to request, to ask you for it, even
They're
if you happen
myriad.
to pay for it? How could I mitigate the arguments before they even begin, or resistance, or I don't even
Uh,
know where to start that conversation.
well, I did it with my Higginbotham line. I have at the fifth, sixth, seventh, and eighth cousin level, I have Higginbothams in my tree. And I started a project on the Higginbothams because I found about 50 of them at Ancestry, and they were all in the same geographical area. And I wanted them to upload to GEDmatch and or to one of the other companies, and so that I could see what the segments were. And it turned out there were 3 different segments that were there that were Higginbotham line segments. I wrote to them and I said, if I needed to, I said I'd pay for the test, or if they uploaded it, was free at these things, but I would do all the work. All they needed to do is to just upload to GEDmatch or to one of these other free companies. And I was tested there. I would do the work and I would report back to them. And for the benefit of all of the Higginbotham line, I was putting this together and my information was available to them. I would give them my outline of Higginbotham tree, and I also put it in my tree, which was available to them. And I got, instead of the normal 1% feedback that I would get, I got more like 5 or 10% feedback. So it increased the feedback significantly. Still not great, but very helpful. I now have about 150 people from Ancestry that have Higginbotham ancestors. And now I can go in and by grouping methods, I can go out and I can tell people, you are a Higginbotham. If you share your tree with me, or share a blank tree or a tree, or make me a collaborator or a visitor to your tree, I will extend it back and tell you where you connect to Higginbothams. I'll build your tree back for you. And So if I'm willing to do the work, I find many more people are willing to, because there's lots and lots of people that have any kind of a DNA test as a gift. You know, I've given a lot of people DNA tests. I gave it to them. They could care less, you know, what it is. They have no interest in it. Trying to beat these people into submission is, you know, less than 1% chance of doing that. So you have to give them some sort of incentive to do that. A, you're helping everybody else in your family. B, I'll do all the work. C, I'll pay all the money. All I need is for you to just say yes, you know, kind of a thing. And a few more will accept based on this. And I'll keep it all private. You know, you can put your name in as Ralph Blifflespick if you want. I don't care if I'm buying you the test. And there are some people, there's a lot of people that are absolutely afraid of the DNA.
I don't, that's kind of where I've tried the A, B, and C myself, and occasionally it does work, but I thought maybe there are things that I'm not thinking of that, you know, maybe there's a D that I am not aware of. And
Threats of violence.
no, not like that, but you know, it's like, what do people, what are they afraid of?
Well, no, they're afraid of the
Tracking down.
Chinese, of people that get their DNA, their insurance rates going up. All those things are pretty much been debunked. And I belong to a whole bunch of groups that are in this. And if you read my blog post, I contributed to the 25th anniversary of genetic genealogy booklet that's free. If you go to my blog post about 3 or 4 posts back, you can get this free book. So I've been with this business for a while. And if there were some insurance company or somebody that was brokering these things or selling it, you know, doing some nefarious things, we'd know about it in a heartbeat. This would be all over. All of us would be talking about it. Every now and then, there's a story about somebody, some criminal that got caught, and they used somebody's DNA to do that they shouldn't have. Well, that's like saying, don't anybody jaywalk anymore. You know, come on. There are going to be people that are going to jaywalk. Few people are going to break the rules. But by and large, very few people do. And there's been no catastrophic problem there. But the people still harbor these feelings. And they just don't. Maybe they know something about their ancestry that they don't want to have discovered. I don't know. You can make up 100 different stories about how this works. One of the ones that I like, when you get somebody that says there might be a question mark in my ancestry, the answer to that is to say, yes, there might be a question mark in your ancestry, but if you find it out first, you can manage it. And there's a million other people out there that are looking at it. When they find it out first, you know, they can blast it all over the place. They can do things, you know, and so you're better off managing the issue than hiding from the issue, if that's the case.
Yeah,
The estimate is that about 80% of all the people in the United States anyway can be found through DNA identified.
All right.
I
Any
have,
other questions? Gig folks? Alan, did you have a follow-up?
well, I just happened to think of I have a cousin's kid that I've been trying to get to take. The cousin has passed away. And I'm like, you know, if you're if you are an axe murderer that left DNA behind, you know, they would have found you by now, because I'm not the only one who's taken a DNA test. Your
Right.
sister has, your cousins have, you know, it wouldn't have been hard to find you at this point. So you're not risking much here.
Oh, Alan, you're trying to use logic.
Good point.
You know, like, even if you have 3 illegitimate children in the world today and they took a DNA test, they're going to find you. You can't hide.
Yeah.
So
I've traveled. I was in the Navy for 30 years. I've traveled all over the place, and someday there might be somebody pop up that I didn't know about. I don't know. Hard to say.
along that line, though, DNA has been really fun for me. I gave 2 people in Denmark their history and got to meet 3 generations of the one family. And another, we determined that my cousin had a child out of wedlock that he probably never knew about. He was like 18 years old, and his children were delighted, and they got to meet their half sibling and their half sibling's child. So those are really fun stories.
Yeah. I've got 2 good friends now. And one in particular was a Navy captain with me, and we served together for a while. And she is Italian family, went to Notre Dame, devout Catholic, took a DNA test. She's 50% Jewish. Holy cow.
Whoops.
And her parents long since gone. And that was one of my first bottles of wine. She and her husband went on vacation with my wife and I, and we sat down, put a bottle of wine on the table and said, okay, let's work through this. And that one was not hard at all. Within a couple of hours before the wine bottle was done, we had figured out her Jewish side, because here's these Jewish matches, top Jewish matches, Weinberg and Cohen. And then we looked at them and we figured out where a Weinberg married a Cohen. And so that had to be her grandparents, you know. And so 5 children, 5 sons all went off to World War II, came back. She was born in 1954, and 4 of them came back to Pittsburgh. 1 of them went to New York. Well, as it turned out, he was living about 5 blocks away from where her parents were living. That's a case closed. You know, let's finish off this bottle of wine. Not hard to do when you have a case like that. That was fairly easy to figure out. Some of them were, I have another case where I have a good friend of mine. We were the same Y DNA and a very unusual Y DNA on the Bartlett line. And his grandfather was he wanted to say he was an orphan, but I think he was a foundling, not a foundling, but a foster child, because he knew his surname. He was surnamed Bartlett, and his DNA was Bartlett. So I don't think he was an orphan or adopted somewhere. So anyway, we've never been able to find out who his grandfather was. I know who his great-grandfather was, and his great-great-grandfather, and great-great-grandfather, which is my great-great-great-grandfather. And we know all about, I know his mother and all of his ancestors I can figure out. But the one person that would have been his grandfather was a tick mark in the 1840 census record, you know, and then he either married this girl or had an affair with the girl and then died, or between 1940 and 1950, 1840 and 1850, he might have gone to California in the gold rush, never to be heard from again, died along the way, who knows, but this guy just sort of disappeared. We cannot find him anywhere. And it might just always be a Mr. Unknown Bartlett in that tree. So those kind of cases do happen, but you can figure out, because there are so many parents and grandparents and great-grandparents who are normal people who are in the census records, married each other and left wills and deeds and all kinds of stuff. So you can find the rest of them. But getting down to that one individual often is hard. And when you get stuck with a bioancestor and everybody's plugging at that bioancestor and everything like that, get around that, go around that and listen to the matches. Forget everything that you've been told and see what the matches consensus is in the way of ancestry out there. And you can build the trees for the ancestry stuff. You might still have an empath, you know, you might still get down to this one guy that was under a rock and died before he left another record, but at least you can be pretty sure that it was that guy, you know.
Well, Jim, you have kept us lively entertained, and we've got a lot of people on the call still. I've been looking, and I'm curious to see if anybody who's been quiet and who has their video image off, they want to talk or ask a question. Otherwise, I think we've been pretty far over our scheduled time. Joel, do you want to comment?
excuse me, could I just ask one quick question? Jim, do you still go to the Family History Center?
No, I have a monthly Zoom there with the group that I lead there, the Advanced Genetic Genealogy. There's a Family History Center for the Washington, D.C. area has 2 DNA Zooms. Mine's on the second Wednesday and the other one's, I think, on the third Thursday of the month. And I'm taking the summer off this year.
Thank you.
I'll be
And
back on
thanks for your
in September.
presentation.
Yeah,
Yes,
you're
thank
welcome.
you very much.
We had a good time, lively group. I'm going to stop the share here. See if I can get the.
I think I'm gonna have to start stocking up on wine.
If you're going to deal with me.
Yeah. By the case, no doubt.
I have another group, a group of us that when the advanced genetic genealogy book first came out a couple of years ago. Let me get this.
Yeah,
This is the advanced.
one.
Yeah, you got it.
yep.
So I wrote a chapter for this, and it turned out it was the first chapter that they put in there because I was the one that was the most advanced in there. And a group of us got together to talk about that book, and we've stayed together since then, just sort of like a little study group. Most of them pretty much involved in the genetic genealogy, and so we normally have a glass of wine in our Zoom sessions, wine and chocolate. So it's a lively group and good questions, all of y'all. I enjoyed it.
Thank you very much.
I don't
Thank
have
you.
anything.
Thank you.
Okay, thank you all.
And I have a question for the gig members, Joel, if I may be very bold.
Please.
Listening to the discussion on triangulation, I'm wondering for the gig members on the call, would you be interested in a follow-up presentation focused on triangulation groups?
Mhm, mhm.
Raise your hand. 2 hands counts double. All right. Thank you. Joel, it's yours.
I think we all have gotten a lot more homework to do here.
Mhm, mhm, mhm.
Do you want to say something about our next meeting?
Oh, okay. Well, first off, Jim, I so appreciate your energy and your preparation and the materials you gave us. Thank you so much. In July, we will have Rebecca Covert. You may know of her, Jim. She will be presenting on the use of evidence and developing proof in genealogy to remind us about data and information quality and staying rigorous in our evaluations. August is off. In September, we will have Liv Merritt Haakenstad, who is a Norwegian genealogist, talking to us about immigrating Norwegians and data sources on the immigration of our Norwegian ancestors to the US. And October is open. So I'm looking at gig members, even those whose names show but faces do not. We are looking for volunteers. You're on notice. And for those also who have a problem, who might have a brick wall for whom they want the advice and counsel and psychological healing of talking to us and us giving suggestions. So October is currently open. We have January currently set. Katja Janssen is going to be, or Jacobson is going to be presenting 2/3 of it on the plague occurring in Norway in the episodes, and I'll present 1/3 on the consequences, economic, historical, governing, etc., of the plague in Norway. So that's the next few months.
Thank you very much. And of course, yeah, thank you, Jim, for a great presentation and a great discussion.
Well, thank you. I
very much.
enjoyed it.
Thanks, Jim.
And you offered, if you wouldn't mind, send me your PowerPoint and we'll
Will.
distribute it to the group.
Okay. It's got a lot of other stuff in there that might be interested too.
Yeah.
You're keeping us busy.
Yeah.
Okay. See y'all.
Great.
Bye.
Thank
Bye.
you very much.
Thanks, everybody. Have a good
Thank you.
month.
Thank you.
Bye.
Well, it's just the family here now.
Hey, turn yourself on, Tona. Are you still there?
I'm still here.
There you are.
Just have to find the
It's
Yeah.
still raining in Minnesota.
Oh,
In case you're
now
wondering.
it's raining here too. Cold and raining and
Yeah,
windy.
it's just hot here.
Yeah.
It's so weird having had drought for 3 years and a lot of heat, and now it's temperate and rainy, really rainy.
Mm.
Yeah, I was talking to my brother in Arizona, and he calls it the monsoon, but they got heavy rains filling up all the gullies, and all of a sudden there's water everywhere, which is rare in Arizona.
Where does it go in Arizona? Does it have to find a river or does it go in the ground?
Ultimately, ultimately I think it goes to some river. I don't know which one, the geography that well, but
Where in Arizona does he live?
he's in Tucson.
Oh, down south.
Yeah. He at least his claim is that Tucson is very good at managing water, whereas Phoenix is really bad. In Phoenix, they all have yards and they water them and all that kind of stuff. So Phoenix is running out of water, but Tucson is hanging on okay.
How hot is it?
Oh, I spoke to him yesterday, and he said it was 102, which was cooling off. It was much better than it has been.
Wow. No thanks.
But like they always say, it's dry heat. The humidity was like 5% or something like that.
Oh, that's a little more easy to tolerate.
Well, it's good to see all of you.
Are you at home, Tona and Hunefos? Or are you?
No, I'm
Uskedal?
in Uskedal,
Oh,
Oh,
but we are going to Voss next on Monday.
all
We are
right.
going to this mountain farm. We are attending to 3 cows. We are being, what do you call it? We are helping our daughter and Cecilia and her husband Christian
Yeah.
milking 3 cows for a week.
Only
Great.
3?
3 cows, that's enough. It's heavy work.
Is it? Oh,
The
okay.
rest of the cows are out in the mountains. They are free. They have their holiday, but they keep 3 cows at close to this what do you call it? Seta.
Oh, like a cabin or something up in the mountains?
Yeah, almost all farms has a seta where they keep the animals during summer.
Yeah.
Earlier nowadays, and now they try to keep the vegetation down by having the animal out in the
So
fields.
there are no fences.
No fences.
Oh.
But these 3 cows is in fences,
Oh.
and
You
we
don't have
milk
to go.
them.
You don't have to go find them.
Yeah, we have to ship them to the house to milk them,
Oh, okay.
and then Cecilia will make some cheese out of it. It's a state thing. They can have money from the state to keep the cows milking.
Oh. Just the two of you do this? Just you and
Yes.
Cecilia?
Me and Niels are